Okie dokie, welcome back. Now I'd like to solve a physics problem with forces, including friction. So if we return to the previous situation where we had this block, which we called Bernie the block, and we come along and give him a push, we start with the same parameters that the applied force is 100 newtons, that the mass of the block is 10 kilograms, and add one additional piece of information, mu. Mu is the Greek M-sounding word. It's actually pronounced mu, but physics people usually say mu. It's a coefficient, and that coefficient tells us how rough the ground is, basically how much friction will be produced. But doesn't have any units, that's why it's called a coefficient. And mu is used in this friction equation. The force of friction depends on two things. One, the roughness of the surface, and two, the amount of normal force between the surface and the object. So we're going to use this and include it in our force equations. One other thing to keep in mind is the force of gravity on an object is mass times g. 9.8, we'll call that 10 for our purposes today. So, like usual, the first step when solving a problem like this is to draw our forces on the force diagram. So I have gravity always acting straight down. I have the normal force acting up. I have an applied force pushing forward, and now I have friction pushing back. No angles in this problem, like we saw last time, but because we have meaningful forces in both the vertical and horizontal directions, we're going to set up Newton's second law in X and in Y. So I say net force equals mass times acceleration. And if I call right forces positive and left forces negative, then in this diagram I see that there's a force pushing to the right, applied force, and a force pushing back is the force of friction. And that will equal mass times acceleration. Well, I know the applied force, but I don't know a frictional force. All I know is the roughness of the ground and the mass of the block. In order to find the force of friction, I need that coefficient of friction, but I also need to know the normal force. So, let's come over into the y side. The net force equals mass times acceleration. Now, up forces are positive, so I'm going to say that the normal force is up. Gravity is down, so I'm going to subtract that. And it's not going to accelerate up or down, so I'm going to call that 0. There's no acceleration. What I learned from this is that the normal force is equal to the force of gravity. Okay? Well, what's the force of gravity? The force of gravity is mass times g, which for this block is 10 times, we're going to say 9.8 is close enough to 10, where we get a normal force which equals a gravitational force of 100 newtons. So, coming up here, looking at this equation, now that I know the normal force, I can use it to find the force of friction. I'll just write that in here. Fa is, instead of force of friction, I'll say mu times the normal force. Mu times Fn equals ma. By the way, sometimes it's effective to write in variables. So I could write in, instead of Fn, I could say m times g. In a case when I don't know the mass, I might realize that there's a mass here that might cancel masses in other terms in the problem. In this case, we've already solved for the normal force. It's 100, so I'll write that in. So we have an applied force, this person pushing the block with 100 newtons. We have 0.4 is mu, and we have the weight of the block, which leads to a normal force of 100 newtons. The mass is still 10, and I have acceleration here. And I find 100 minus 40 equals 10a 60, and therefore I have an acceleration of 6 meters per second squared. So I'm using simple numbers here, like 110 and so on, so that you can get the concepts. But notice the general flow of the problem. I look at what's given. I draw a force diagram with my arrows showing those force vectors, giving me the direction and giving me the magnitude. I set up Newton's second law. Net force equals mass times acceleration for both x and y, and I solve for what is missing. Now, we're going to move on in the next video to include both friction and angles, and that makes it just a little bit harder.